GNF. So it is a pre-processing step, we have to remove null unit production and all the things we have removed, like a null and unit production, and convert the grammar into a given form of CNF, right? In CNF we will have this format, non-terminal gives you non-terminal into non-terminal, or will have single terminal, right? So in like the way we have to convert it. So that is a pre-processing step. After that we have to make for the considering rule of GNF. So the second rule will says you rename all the variables as same variable name with different subscript. For example, if SAB capital letter or variables then those are renamed as A1, A2, A3 respectively. So what are all the variables available in our productions, we have to convert it in the same order. For example, if S production is coming first, so we have to make it as A, and in the same S production you are getting S gives A, B, right? For this A you have to substitute A2, and for B you have to substitute A3 respectively. So this is the rule number 2. After this, choose the production just such that the left hand side or variable subscript is greater than right hand side, greater than or equal to right hand side variable, right? So if the production is of the form A gives Jx, then I is less than J, and it should never be I is greater than or equal to J. So always I is less than J, and it should not be on greater than or equal to J. So when it is going to be happen, we have to choose a production of the left hand side variable. So that is the first production. We have to choose it and we have to apply it. When we go for the problem, it will be very clear, right? So this is the rule actually. After this rule, I'll going to explain the problem. So then you will understand very easily, right? Okay. So fourth step is apply lemma 1 or lemma 2 accordingly. So what is lemma 1? We'll see that. So let G equal to V, T, P, S, B, S, C, F, G. Let A gives B alpha, be a production in B. So B gives beta 1, beta 2 up to beta n, be the set of all B production. Let G dash equal to V, T, P dash S be obtained from G by deleting the production. A tends to beta 1 alpha or beta 2 alpha up to beta n alpha, then L of G equal to L of G dash. So in the sense, it is a simple rule. When we see this sentence, it looks like a complex one, right? But it doesn't matter actually. Whenever what are all the production occurs, like A tends to B alpha, and suppose we'll have this another production for B tends to beta 1, beta 2, beta n. So we have to substitute. It's like substitution rule, right? So what are all the places available for B, we have to substitute this beta instead of B, right? So A tends to beta 1 alpha or beta 2 alpha up to beta n alpha. It's a simple rule only. So when you go for the statement, it looks like it's messy, right? Okay, fine. So this is the lemma 1. This is only a simple substitution, right? After that we'll go for the lemma 2. So we'll see the lemma 2, right? So in lemma 2, let G equal to V, T, P, S, B, S, C, F, G, and let A gives A alpha 1 or A alpha 2 up to A alpha n be the set A production, for which A is the leftmost symbol of right hand side. For example, when you choose this lemma 2, right? So if I'm having the production like this kind of, for example, A tends to A alpha 1 or A alpha 2. So for this here, you have to choose like A tends to beta 1, beta 2 up to beta n, be the remaining A dash productions. So we'll see when you come for the problem, it will be very clear, right? So actually, when we apply for before applying lemma 1, lemma 2, we have to choose which production to be used for the first thing, right? Which production you have to choose it for applying lemma 1 or lemma 2. So when we when the particular condition is happened, right? If I is greater than or equal to j, we have to apply this lemma 2. So for this condition we have to apply lemma 2. After that lemma 2 condition has been got over, we have to apply a lemma 1 accordingly. So I'll tell what are all the situation over there. So this is for lemma 2, especially the lemma 2 is used to remove left recursion. So left recursion, I'll tell you what is reflected and the problem comes, right? So after that, let G dash equal to V union Z T P dash S be the CFG formed by adding the variable Z to V and replacing all the A dash production by the following. So A tends to beta I and A tends to beta I Z. So such that I lies from ranges from 1 to m. Similarly for Z, we have to introduce two terms. One is alpha I or alpha IZ, where I tends from 1 to m. And my fifth rule is repeat or applying lemma 1 or lemma 2 for all the production till my grammar comes into GNF, right? Okay, we have seen the rules of GNF. Then we'll go for what is GNF. So GNF is a form of CFG is said to be GNF if all the production have the form A tends to small a alpha and A tends to A, where A is a terminal which is A belongs to T and alpha may be any number of non-terminals. So it is small a followed by any number of capital letters, which means any number of non-terminals. Only a single a followed by a non-terminals, or it is a terminal, single terminal, right? So this is the thing. So now we'll directly go for the problem and we'll see what are all the things we have to what are all the things we have to need to apply for lemma 1 and lemma 2. Now we're going to see about that, right? Okay, so for this, construct a grammar in GNF equivalent to the grammar S tends to AA, A tends to SS or B. So when I see this grammar, so what is my first rule tells? Eliminate null unit production and convert the grammar into CNF, right? So here there is no null production, there is no unit production, and also so see here S tends to A and A tends to, so S gives A, right? And A also gives, you have SS or B, and it is also in the form of CNF. So it should be and convert the grammar into CNF. So what is CNF rule says? So CNF is having the condition non-terminal gives non-terminal into non-terminal or a terminal. So we are getting this thing. So it is not a problem, right? Next, rename all the variables same variable name with different substitute. For example, second rule we have to apply here. So solution we have to write it here. Write it. So the given grammar has no null production and unit production and is also in CNF right? Okay, so now I rename the variables, right? Variables S and A are renamed as A1 so we'll have only SA, right? So for first production, so we have to go for A1. For the second for the first variable, you have to go for A1. For the second variable, you have to go for A2. A1 and A2 respectively, right? So there is no other variable, so we have to rewrite this rule. So as we rename, we have to rewrite this production. Rewrite the production as A1 tends to A2, A2A or A, and we'll have A2 tends to A1, A1 or B. Right, this is all. So after rewriting our production, our rule is like this. So S and A replaced by A and A2. Fine. So this is my steps 1, right? Okay. After that, we have to apply lemma 1 and lemma 2 accordingly. So see here, if the production is the form AI gives to AJX, then I is less than J and should never be I is greater than or equal to J. So see, I is less than or equal to J, and it should never be I is greater than or equal to J. So here, so this first rule is okay, and when I see for the second rule, it violates, right? So I is greater than or equal to J. For this, in the scenario comes, we have to choose a production such that the left hand side variable subscript is greater than right hand starting variable subscript. So we have to choose a second rule for applying lemma, right? So when it is having I is greater than J, you have to use lemma 2, right? Okay, so now choose rule 2, right? So this is my step 2. So this is my step 2. Choose rule 2. The rule A2 is, so A2 gives A1, A1 or B, right? So now replace first A1 on right hand side by A1, right? So actually this is going to be a substitution technique, which is known as lemma 1. So we have to substitute this A1 for the value of rules 1, right? Okay, so then therefore A2 productions are so A2 gives, so we have to substitute, right? So for actually we have to substitute for this only, because my GNF satisfies A tends to single terminal followed by any number of non-terminals. So we have to apply only for the first variable in the right hand side. So we have to use, right? So A1, for A1 we have to substitute it. So A2 A1 or A1 or B. So this is my A2. Okay, so this is my A1, sorry, this is my A2. So when you see this, you have A2 and A2 here. So when you having both or same in the left hand side and the right hand side starting variable or same, this is known as left recursion. So this is known as left recursion. So when you see this kind of left recursion, you have to apply lemma 2. For this you have to eliminate it by using lemma 2, right? So left recursion should be removed. Apply lemma 2, right? Okay, so according to lemma 2, see this how I apply here, right? According to lemma 2, A tends to A alpha. So my rule over here. So see this, my previous rule. So the same rule will be applied. I'll tell you what we will do, right? A alpha or A alpha 2 until A alpha n or beta 1 beta 1 or beta 2 up to beta n, then A tends to beta 1 or beta 2 up to beta n, and again A tends to beta 1 is it, beta 2 is it, and beta n is it. Okay, after that we have to write z terms alpha 1 or alpha 2 up to alpha n. Similarly we have another term alpha z, alpha 2 z up to alpha n z. So this is the way we have to write it. Okay, so for this we'll have this production, right? For this production we have to apply. So here so A alpha and also up to beta up to n. So we have to check it, right? For A to A2, so here A and A. So for this A will be A2 here, and after that you will have this alpha, and this A1 goes for beta 1. So because of beta 1 is it, so see here be the remaining production. So A tends to be beta 1 or beta 2 beta n and be the remaining A production. Okay, so we have to make it. So here A equal to A2, alpha 1 equal to, see my rule, so A equal to A2, and alpha here is, so see this, so you have to left this A2 and alpha is A to A, and again only one term for A2 alpha 1. After that this is for an separate, so which is known as beta 1 beta 2 production. Okay, so alpha 1 equal to A2 A1, right? Beta equal to beta 1 equal to A1, beta 2 equal to B, right? Okay, now we have to apply this 4 rules to this A alpha, right? We have to apply for these 4 rules for our this conditions. So A2 tends to beta 1, see here, so A2 tends to beta 1 beta 2 up to beta n. So what is beta 1? So A1 or B. After that A2 in terms of z we have to write it, right? Z bz. Okay, after that we'll have z rule. So for z rule, see this, one time as alpha and another time for z terms, right? Alpha 1. So only we are having alpha 1. So A2 A1 and another one is A2 A1 is it. Okay, So now see here, this is already in GNF, and this is also because single terminal followed by non-terminal, single terminal followed by non-terminal. So this is also GNF, this is also GNF, but this is or not in a GNF. Why? Because single terminal followed by a non-terminal should be there, but here everything is in non-terminal only. So we have to convert it. So next one, we have to go for next step, right? So next step is step 3. So for step 3 we will go for now consider the production. Now consider production A1, right? So A1 tends to A2, A2 or A, right? Well, actually we have got A2, right? So we have to apply this A2 for this A1. So now replace first A2 on RHS by its recent GNF rules, right? GNF by recent GNF rules. Okay, so A tends to will have A2, right? So we have to apply this rule. So A2, A1. So we have to apply only for this first variable in RHS. So that's why we have to apply. So that's how we have to apply, right? So A2, A1 or B, A2, or we have to apply this one. A1 is at A2 or B is at A1 is it or B is it over here over this production. So for this A1, A2, so first A2 we have to apply it, right? A1, A2, after that B, for this A2 we have to substitute B, A2, or we'll have the second one, right? So A1 is it. Finally, you will have A2. After that, B is it, right? So for A2, you have to substitute B is it, A2, and finally, so this is my B, right? So finally, my A is there, right? Okay. So this is my A1 rule. So after that, we have this. Now consider Z rule, right? Now consider Z rule. So for Z rules, we have this, right? Z tends to A2, A1, and Z tends to A2, A1, Z. So we'll have this 2 rule. So replace A2 at RHS. So for this, we'll have to apply A2, right? For this, we have to apply. And so what is A2 now? So for A2 is already in a GNF form, right? So for when we consider this, A is now in GNF, A1 is now in GNF, because see here, so we have converted A1 into GNF because terminal followed by a non-terminal, and terminal followed by non-terminal, terminal followed by any number of non-terminals. Similarly, terminal followed by non-terminal and single terminal. So similarly, we have to replace for Z rule. So Z tends to A2. For A2, we have to substitute it, right? So A1, A1 and A1, right? Okay. After that, B, A1. Similarly, you have to apply for this A1 is it, A1 is it, and after that we'll have this B is it, right? So B is it, A1 is it. So this is my is it rule, right? So A1 or B A1 or A1 is it, A is it, and B is it, A1 is it. So here we'll have this, right? This now after applying is it rules. So to replace A2, so here we'll have this A2 rules. So here, so for A2, A1 or B, A1 is it or B is it, we have to replace all this A2 by this right hand side productions to Z production. So after applying this, we are getting this Z rule. So these are all in the form of GNFs. See here, terminal followed by non-terminal, similarly terminal followed by non-terminal. So everything it is comes around, you have this in a GNF form. So for Z rule we have converted, for A1 we have converted, so only we are having A1 and A2. So for A1 we have converted all the rules, and for A2, we are also having this format. See this, so it is also in a GNF, and Z rules also converted into GNFs. Okay, so this is known as GNF conversion. So thank you.